corner then?
Only if it's a corner.
Okay.
Or a cusp. Polynomial functions are friendly functions. No problems whatsoever.
So,
this is an example, let's say, of an absolute value. Absolute value of x. It has a derivative everywhere, a rate of change, instantaneous rate of change everywhere except here. So polynomial functions are always continuous, and we say also differentiable.
I'm confused because I thought the limit was just what as the x approaches
right
a certain number, what is
right
the y value?
So let me hold your thought. So the derivative function, this is the notation, f prime of x. So f prime of x is the limit, of course, when h approaches 0, from f of x plus h minus f of x divided by h. So f prime gives the instantaneous rate of change of f of x at any point, wait for it, where f of x is differentiable. So what this really means is, if the slope from the left and the slope from the right are equal, and they exist and they are equal, left of h of 0, right? So the limit from the left of 0 as h approaches 0 from the left equals the limit as h approaches 0 from the right. If they are both the same, then this function exists at that point. See here, the limit of the difference quotient from the left is a negative number. The slope is negative. Sorry about that. And the limit from the right as the slope, it's positive. This is a positive slope, this is a negative slope. The limit from the left, as x approaches 0 from the h from the left, as h approaches 0 from the left, the slope is negative. As h approaches 0 from the right, the slope is positive. So for the 0, the limit as h approaches 0 from the right will not equal the limit as h approaches 0 from the left, which means f prime does not exist at 0. Do you feel better, Alex, now? Yes?
It was me asking questions.
Oh, I'm sorry, Lyndon, I'm sorry, forgive me.
No, it's okay.
Do you feel better? Remember, this limit, I don't care what this is, but this limit exists only if the limit from the left of 0 and the limit from the right of 0 exist and they're the same number. But here, they exist, but they're not the same number at 0.
What is h there?
From the difference quotient.
Oh.
So this is the derivative is the limit of the difference quotient. So in other words, when I bring q closer and closer to p, from the left, from the right, and from the left, do I get the same slope? If I do, then the limit of the difference quotient exists and the function is differentiable at that point because it has a unique tangent. But if I have a situation like this, this is a corner. Look, the slope on this part is definitely smaller than the slope on this part. They're not even the same, even if they're both positive. This is much smoother than this. So the derivative here, the slope of the tangent line here is 2, and here is 5. So on this side is 5, on this side is 2. Therefore, at this point, there is no rate of change, because the two limits from the left and right are not the same. Very good. So let's find the derivatives of some basic functions. Let's say f of x equals x squared. I can find f prime of x, just copying the definition, the limit as h approaches 0 from f of x plus h minus f of x divided by h. Exactly what we did before. This was discussed a long time ago. This we've been discussing for a couple of weeks, a week and a half. Now we are putting them together because we want this. That was the whole purpose. That's why I talked to you about this, and then I talked to you about this, so now we can put them together and come up with a different concept. Okay, so then limit as h approaches 0. This is very simple. It's x squared plus 2xh plus h squared minus x squared over h. Because I plugged in x plus h. We know two things have to happen. Absolutely mandatory. All terms without h must go away. They do. Then I have limit as h approaches 0. We know that we have to factor out h, because this h has to go away, as we learned for a couple of weeks, 3-4 weeks already. Can anyone give us what's left in parentheses?
X plus h.
Very good, awesome. Thank you so much. Who was that? F. Thank you. Good. Okay, now, careful. The limit operator stays with us till we apply it. Now we are ready to apply it. Can anyone give us the final answer?
Plus h.
Can you?
2x.
Excellent.
Good.
Excellent. So moving forward, very easy to remember now. What is x squared prime? What does it equal to?
2x.
That's it. Awesome. I'm going to...
confused how you got the 2x, by the way, from the 2x plus h.
You apply the limit. Let's apply the limit.
Oh.
Apply the limit. Better?
Don't you? Oh, okay. Okay.
Good? Okay.
Yeah, I was still thinking we were applying it as x, but I saw it was h.
Yes, that's the tricky part here. I agree. Good. So let me share my screen. And I want to put a page number in here. And the page number I want to put in is 145. Okay, so let's look at 29 and let's discuss 29 for a minute.
I have a question about
Yes, Tess, go ahead.
If we use limit, there is h over there, so it don't be 2x plus 1.
But h does not approach 1. You cannot change h to 1. H approaches 0.
There is in the parentheses, there is h. How we eliminate that h?
We are applying the limit. We apply the limit to the expression 2x plus h. What do we get?
So h becomes 0. Because that's the limit.
Is that okay?
Oh, we plus it. Okay.
Is that better? You cannot put 1 in here because age approaches 0. You can't change that. That's the definition.
I was not. I mean, froze by old age, not by using the limit. That's what I was doing.
But is it better now?
Yeah.
Okay, perfect. So let's look at 29, for example, or 30, it doesn't matter. And let's discuss what's happening here. So is this function continuous at this point?
Yes.
Yes.
Is it differentiable at this point?
I'm still not sure what that means.
It has only one tangent. When I graph the tangent, it has only one tangent. So let's go back here.
Yes.
Since this function has a corner, I cannot draw a unique tangent at this point. There is a tangent on this branch, and there is another tangent on this branch. So there is no unique tangent. For example, here, yes, go ahead.
I was going to say yes then.
Yes. So here I can draw one tangent. Can I draw more than one tangent at this point? No. What about this point? Can I draw more than one tangent? No. Even if I want to, I can't. What about here? No. Just one tangent. So at all these points, the function is continuous and differentiable. So back. Is the function continuous at x dot 1 or x sub 1?
I have a quick question.
Sure.
No.
So differentiable means that there's only a single tangent at a point?
Yes. So first of all, it means that the function, I lost my page. No, I didn't. So first of all, it requires that the function is continuous. It requires that the function does not have a vertical tangent. And it requires that the function does not have a corner at those points. If it's not continuous, vertical tangent, or corner, the function may be continuous, not here. It may be continuous, but not differentiable. It has to have one tangent. So is the function continuous at x1?
No.
No. Should we talk about differentiability?
No.
Absolutely not. Perfect. Awesome. Is the function continuous at x sub 2?
No.
No. So there is no tangent. If it's not continuous, there is no tangent. What about at x sub 3? Is the function continuous at x sub 3?
No.
Continuous.
Yes.
Continuous.
Yes.
Good.
Yeah.
Is it differentiable? Does it have only one tangent?
No.
No. It has a positive on this branch and a negative on this branch. So at this point, this is a cusp. You can call it a corner, I don't care. The function is continuous but not differentiable. What about at x dot 4? Is the function continuous? No, we cannot talk about differentiability. What about x sub 5?
Yes. Yes.
Continuous. Does it have a derivative?
Yes.
Yes, because there is only one tangent. Would you like to pick anything from here or we move on?
Move on.
Okay, let's move on then. I want to look at something like this. So let's choose something from here. Draw a graph that is continuous with no corners, but not differentiable at x equals 1. Continuous, no corners, but not differentiable at x equals 1. I can only think of one thing. That x equals 1 is continuous? Yes. Is it differentiable at x equals 1? Why?
No, because it's vertical.
Vertical tangent. So it's not differentiable because that limit is infinity. This limit is infinity of the difference quotient. Very good. Okay, so let's do one more thing before we continue. Let's also determine for function the square root of x, find its derivative. So this is called the first derivative, or just the derivative.
Can I ask a question?
Yes, any question.
What's the
That's
meaning
fine.
of the one that you keep putting after half?
You mean here?
Yes.
It's the apostrophe. So let me, it's a good point. I'm just opening where are you guys? I lose you when I open other. Okay, so when I type, for example, it's just f prime, okay, of x.
Okay.
Okay, so with lowercase, it will be f prime of x. Oh, I thought I changed that. Now I did. So f prime of x. Is this better? So apostrophe, f prime of x. Okay? Good. So we want to find f prime of x, the function whose derivative is this, whose the derivative of this function, which will give us the rate of change of this function at any point where the function is differentiable. Can anyone give us the domain of function f? We discussed this many times.
Greater than
0
or equal
to infinity.
0 to infinity, right? Correct?
Yeah.
Good. So now let's find f prime of x. How? The limit as age approaches 0 from the square root of x plus age minus the square root of x divided by h. What do? Always with something like this.